Okay. Well, first of all, thank you for coming to the What's New session for Aqua-Tech, provided by NACHURS. Just to get started, my name's Wayne Becker, and I'm a sales agronomist for the southern region. The company, NACHURS, has been, we're actually in our 70th year of producing the highest quality liquid fertilizers and helping farmers find solutions to push productivity and by applying nutrients in the most efficient manner possible. And with that, we have a new product called Aqua-Tech. That's what we're going to talk about here today. So just to get right on into it, it's about fertigation and irrigation. As you can see, irrigation, you very well know, is extremely important to the United States, with a large portion of the United States, their agriculture being 90% more dependent on irrigation. And with all that, there comes water problems and water concerns and less water and efforts to become more efficient at all times. In general, agriculture has been pushing efficiencies and trying to figure out how to do more with less, and that's what we're talking about. Water in general and irrigation, we're finding better ways, moving from flood irrigation to pivot irrigation, moving from pivot irrigation to drip irrigation. So we're looking for more efficient ways to apply water, and we're also looking for more efficient ways to produce crops with that water. Just providing water more efficiently is just part of the picture. To do the best job with irrigation, you also have to concern yourself with the other inputs, such as shown by this slide. First and foremost, the brown lines kind of show us that varieties make a big difference, and high inputs with good varieties give us more yield. Under irrigation situations, you use the proper varieties and you push that yield further, but then really take care and really look at those inputs on top of varieties, we can really push efficiency. So efficiency is about inputs as well as providing the water the best way possible. So that's why we're going to talk about fertigation today, because fertigation and fertilizer is an input that we can put in with the irrigation water to push those efficiencies. By fertigation, simply I'm talking about the application of fertilizer material via an irrigation system. That's pretty simple, straightforward, should make sense. Now, it's very common, especially through our subsurface and our drip irrigation systems. And that's where we're going to focus our thoughts today. Subsurface, surface, and sprinkler irrigation, I should say. And really, the fertilizer material that's catching on the fastest is nitrogen fertilizer. It's becoming very common. That's not necessarily what we're going to focus on today. We're going to focus on the other nutrients, maybe especially phosphorus, things that are more difficult to put in with that irrigation water. So, why do we want to fertigate? Because when we apply nutrients with the irrigation water, the nutrients are already going to be in that soluble form. And the soluble form is very important for nutrient uptake. You're going to be able to apply the nutrients directly to the root zone of the plant. So we're able to put them where the plant can reach them the most easily. You can time those nutrients to coincide with crop demand. We all know that time is not our friend with nutrients. They're either binding up in the soil, volatilizing, or leaching out. We're losing nutrients. So when we are able to spoon feed, that timing is very important. Also, with an irrigation system, we can eliminate our application expense because you don't have to put more trips across the field. Therefore, you can spoon feed even more effectively with multiple applications. It's all about saving time, being environmentally friendly, wasting less, getting more out of your nutrients, increasing your water use efficiency because of the nutrients, and of course your nutrient use efficiency, and ultimately getting a stronger, healthier crop. So, with all those benefits, we have quite a few concerns. Our fertigation concerns, first and foremost, are the expense of getting the equipment to do it. We may have an irrigation system, but now we also have to have an injection system, and that can be quite expensive just getting that up and running. You also will have management concerns. There's the issues in timing, in moving product, planning ahead, several management concerns of that nature. Fertilizer handling issues. We need to have the fertilizer to a place in a timely manner. We're probably going to put on more applications and spoon feed to get the highest efficiency. So getting it in there in a timely manner is a concern. In general, you'll be getting the fertilizer next to the injection site on a regular basis. And sometimes that might mean that you have high volume of products that you have to handle. But also, sometimes that means that you're going to need to have more acid flushing, or you're going to be using an acid fertilizer. Aqua-Tech is not an acid fertilizer, but in the past, that's something that people have used and have looked at. So there's concerns about handler safety because of that, and there's corrosiveness to the equipment that you have to deal with. But ultimately, where we're going to spend most of our time is on the fact that we have poor water quality in much of the region of the United States where we do irrigation. And poor water quality is especially a concern when it comes to phosphorus. For the purpose of this talk, what we're going to talk about as poor water quality refers to hard water. These are the ions that give us trouble: bicarbonates, cations with positive charge, and salts. So these things are what's found in hard water, and hard water is what we're trying to overcome. USGS has a general map of the United States of where the hard water is found. And you can see that they say that all the orange area is very hard, the green area is extremely hard, and the purple area is rock-like hardness. I maintain that it's even worse than this map. So we have a large portion of the United States has a lot of hard water and quite a few problems with hard water. This poor water quality is a real concern because it gives us potential for clogging, especially whenever we're looking at drip irrigation. Our drip irrigation emitters are quite small, and we have to move product through them. Sometimes those minerals can bind with it and cause problems. Also, we have carbonates that'll build up in the lines, causing scale problems, increasing water pressure, and not moving water the way we want it. So water quality is a big deal. Putting fertilizer sometimes gives people more potential for clogging or more problems with their lines and with their equipment. But there's also a part of fertigating that people don't think of quite as often, and that's the potential for problems with either soil interactions with the nutrients or plant interactions with the nutrients that we're not really looking at. And first and foremost, those nutrients can tie up. They can tie up in the water, and they can tie up in the soil. And in the hard water areas, we're applying a lot of salt to our soil just with the irrigation water itself. So let's look at this potential nutrient tie-up, especially with phosphorus. This is an orthophosphate molecule. It's the way the plant takes up the phosphorus. You can see it has negative charges. This is a soil particle. And we know that phosphorus in soil is a problem. When we have a high aluminum content, you've got positives and negatives. They bind up. That's usually a low pH soil. Or if we have high calcium soils, we have the positives and the negatives, and it can tie up. We overcome that in the soil by banding phosphorus quite often, or we might add something to keep that from occurring. Well, that also happens when you're delivering your irrigation water. We don't even get it out the line before it can already be tied up. And so the nutrient availability can be a real issue. The way we're applying those cations or salts or what have you looks different depending on whatever irrigation method we have. But it's a problem. Salts are also a problem. We know that salts compete with plant roots for water. The more salty, the less growth, the less potential we have for yield from our plants. We can increase sodic soil or have sodic soil problems because of salt, where the soil becomes very dense and won't allow for water infiltration. So these are all concerns caused by poor water quality. Keeping all of those concerns in mind, Aqua-Tech was developed. So what is Aqua-Tech? It's fertigation technology for innovative producers wanting to push the envelope. It's designed first and foremost to have greater plant productivity. That's the issue at hand, but also to provide the producer with ease of use whenever they're applying nutrients. Aqua-Tech has two different formulations. The flagship formulation is the 720 and 4, our phosphorus product. We'll talk about it the most. The other product we have is a 2020 plus secondary and minor nutrients. Features for Aqua-Tech, what makes it special, is we have a high concentration of soluble nutrients, with a key being soluble nutrients. Why do we care if the nutrients are soluble? I alluded to this just a little bit before. But for nutrients to move into the plant roots, they have to be carried into the root with the water. If it's not soluble, it's not moving into the root. Liquid formulations have solubility problems. Dry formulations may have or may not have solubility problems as well. Water can dissolve these. Whenever you look at Aqua-Tech, it has the most soluble form of phosphorus that you're going to have available to you as compared to other common phosphorus forms. So we have a high concentration of those soluble nutrients. So we won't have precipitants in the water. More nutrients will be available to the plant. But also, as opposed to some other ways to apply nutrients through the irrigation system, you don't have to worry about the extra labor of dissolving a dry fertilizer first. So you have it in the liquid form with the most soluble nutrients that you have available, so that it saves you time in your delivery system and increases your labor efficiency, because when you have a dry soluble, you have to melt it and move it around, and it actually makes a very low nutrient concentration, where instead of a 720 and 4, it'll reduce it if you add water. You know, it would be a 1, 2 and 1 or something such as that. So you would have to move more product and handle more material once you dissolve it down. In addition to the high concentration of soluble nutrients, we are providing the plant with a very highly available phosphorus source. First and foremost, the phosphorus is in the orthophosphate form. Why is orthophosphate important? Because phosphorus can be applied as a polyphosphate in many cases, which is like a chain link, let's say, where an orthophosphate is a single link at a time. So the plant cannot take up phosphorus when it's all the links linked together as a chain, but instead it has to wait on time and temperature to break it down to a single link and take them up. So it's immediately available, which is extremely important when we're trying to spoon feed and provide a little phosphorus a little at a time. Also, and most importantly, and what makes our flagship product, the 720 and 4, special, is the polyamine technology which it contains. Polyamine technology, who cares? What's it about? Football, pretty easy way to make an analysis or to explain how the polyamine technology works. We have phosphorus as the tailback trying to make it to the root zone. It can't make it because you have the cations that will bind it and control it and stop it. Polyamine technology acts as the offensive line, and it blocks that reaction from happening. So that's what polyamine technology is good for. It blocks that reaction, which ties up the phosphorus. It stops the tackle. Here's what it looks like whenever you do a jar test. This is the exact same hard water, about 400 parts per million hardness. Here is a sample where we added a traditional orthophosphate solution without the polyamine technology. We have made calcium phosphate, which has the potential for clogging and is unavailable to the plant. The Aqua-Tech has been added, and it remains clear. And the phosphorus can move through the soil, be taken up by the nutrients, move through your water, and get to the plant in a much more available and more efficient way more efficient manner. So that reduces the problems with plugging of emitters, especially with your drip irrigation, and it, of course, also means that the plant can take up more nutrients because it stops that reaction in the soil as well as in the water. Another feature of Aqua-Tech is that it contains BioK technology. If you don't know much about BioK, which is not the point of this talk, please visit us at our booth. But BioK technology is quite interesting. BioK, what it is potassium acetate. And potassium acetate is important for several reasons. First of all, it is the lowest salt source of potassium that you're going to find, and it has the greatest solubility. Compared to other potassium sources, the solubility is extremely greater, and at the same time, the salt content is quite a bit lower. So, two good things. In addition to the greater solubility and lower salt content, it helps build rather than degrade soil structure and chemistry. Now, what do I mean by that? The soil has plant roots, it has microorganisms, and it, of course, has your soil or organic matter, and you have nutrients cleaved to that. Roots in general give off exudates, including amino acids, sugars, and organic acids. The acetate portion of BioK is the same thing that plants will give off as organic acids. That's one of the sources they can give off as organic acids. And what that does is it feeds the microbes, helps remove nutrients from the soil particles, and makes the soil environment and structure much better. At the same time, providing a potassium source. Whenever research was done looking at how well do beneficial bacteria in the soil like acetate, comparing it to glucose or sugar, which we know that the microbes enjoy consuming, not only did they consume more acetate, but they also did it at a much quicker rate, so that they, at the end of a study, they took up acetate 350% more than straight glucose. BioK is more rapidly and readily taken up by the plants as well. Acetate is a plant metabolite, is something the plant makes, so it's already in the plant, and having it helps with the energy production for the cell itself. And BioK is not corrosive to your irrigation equipment. Awesome. So those, in short, are some of the benefits of BioK. We also have a very low salt nutrient solution, the lowest form of fertilizer that you're going to be able, lowest salt form of fertilizer that you're going to be able to run through the irrigation system, which of course avoids problems such as that. And finally, it has optimal pH. We're dealing with a fertilizer material that is near that neutral pH. And when you look at where nutrients are most available, that 6.5 to 7 range is about the best. You may have a highly calcareous, a high pH soil, or you may have a very low pH soil. But when you apply Aqua-Tech, the pH is going to be in that 6 range, which is in a range where many of the nutrients are at their maximum availability, as opposed to common ways to apply other nutrients, which have a pH down in the 4 and a 5, 4-5 range, where nutrients may not be as available. So that optimal pH is an important thing as far as availability. What it all ends up doing is equaling greater efficiency. Aqua-Tech technology is about fertilizer efficiency. And that's something that we're in here to learn more about, and that we are really striving to do better, is find better ways to apply fertilizer. We're rethinking what we've been doing in the past, seeing if we can push productivity. Finding new ways to put that fertilizer out, it's not really just about driving the nutrients in the soil, it's about driving the nutrients in the plant tissue. The greater amount of nutrients that you put into a plant, the closer we can get to achieving that maximum yield. This graph pretty much shows that when we're in the luxury consumption area, for the nutrient concentration of plant tissue, we have the best chance at obtaining maximum yield. It's pretty easy to understand how putting nutrients out can keep us away from a deficiency, and that's what we've done traditionally in the past, lots of times with our dryer or traditional fertility programs. But we're missing the boat because a lot of times we may avoid the deficiencies where we see them, but we miss this hidden hunger. We don't realize that the plant still has the ability to have greater nutrient concentration in its leaf and thus photosynthesize better and perform better and push productivity. So sometimes the right type of fertilizer provided in an efficient manner can drive quite a bit of production. A couple of trials that we have. Texas Tech has worked with us on cotton trials. In this trial, we used 35 pounds of phosphorus applied as our 720 and 4, as a broadcast map, or as 1034-0 knifed in. We got 200 pounds of lint for a value of about $100 more an acre. The Kansas State had a trial this year as well, and they looked at corn through drip irrigation, where the grower standard was 44 pounds of phosphorus applied as 1034-0 in a strip pre-plant. The Aqua-Tech was still some 1034-0 applied in a strip, but only 30 pounds of phosphorus. They left room for 14 more pounds of phosphorus to be applied in 3 doses as Aqua-Tech. And when it was applied at V8, I think around V5, V8, and blister, we made an extra 32 bushels on our corn. Very economical, exciting way to do it. 68 pounds more grain per acre inch. Looking at our 2020 product, this slide has a lot in it. There's 2 treatments. They're divided right here with the bars on the left versus the bars on the right, our 2 main treatments. We're looking at our 2020 product applied via a pivot. 4 gallons, 2 gallons applied 2 times. But look down here. The bars on the right received 25 gallons of 28005. The bars on the left received the bars on the right received 50 gallons of 28005. The bars on the left received 25 gallons of 28005. These bars on the left received half the 28005. Now the grower standard is the blue bar. So the grower standard, with no starter fertilizer or no other additional beneficial fertilizer, the 2020 actually produced only 3 bushels less than the additional 25 pounds of 28005. So for 4 gallons of product, we were able to replace 25 gallons of a different product and do pretty well. But what's really interesting is we have a product called Rhizolink, which are beneficial soil bacteria. And in all cases, you can see that they helped push productivity of the corn crop. But whenever you had the BioK and the good things going on in the structure of the soil, the microbes even perform better to where, let's say this pink bar is about 15 bushels better over here with 25 less gallons of 28005. The potential to put some 2020, some BioK, some products like that can really push efficiency as well. So, kind of wrapping everything up, Nature's Aqua-Tech benefits in general, what you can see is first and foremost, our flagship product, the 720 and 4, is the ability to fertigate phosphate effectively. You will not be adding to any scale formation or emitter clogging problems that you have, so you will not need as frequent of acid flushing. That's not to say that the water won't cause some need for acid flushing, but you will not add to your problems with the fertilizer. You have a lower use rate, which helps with precision application, timing, and management in general. Highly nutrient availability, both maintaining viable in the water and in the soil. Improved soil health, improved product safety, which is good for the handler, for your crop, and for the equipment. With that, I'm going to wrap it up, leave you with the thought that Aqua-Tech is unsurpassed in preventing hard water tie-up because of its unique polyamine technology. And it delivers highly available, low-salt nutrients safely and precisely. Thank y'all for listening, and I guess I'd entertain any questions if there are any, or comments. Yes, sir. We need to have you ask them in the microphone. Sorry.
How much does a gallon of 2020 cost?
The question was, how much does a gallon of 2020 cost? And I cannot answer that question directly. We sell through distributors, and the distributor sets the final price. So I really don't have that information to share. You know, any better way to answer that? Come by our booth, and maybe we can hook you up with a distributor and kind of help you figure that out. Or I'll talk to you afterwards, and we'll help you find a distributor. Any other questions or comments? Okay. Well, you look awake, so I appreciate that. And thank you for attending. Have a good day.